today's lab we're going to make calcium carbonate, or chalk. Now we can form chalk by reacting sodium carbonate monohydrate with calcium chloride to make that chalk, and salt water. So the first thing you have to do is figure out how many grams of each reactant you're going to need to produce a certain amount of chalk. In this lab I've decided my goal is to make 2 grams. Your goal is going to be to make 3.00 grams. So you're going to have to do the calculations based on your amount of material you're trying to make. So since I know the grams of the product I'm trying to make, I need to figure out the grams of each reactant. And in order to do that, we're going to use our map of Moltown. So since I gave you grams of our calcium carbonate, the first step you're going to have to do is calculate how many moles that is. So for each reactant, we take our grams of calcium carbonate, we divide it by the 100 grams that are in 1 mole, and that comes from the calcium's molar mass, the carbon's molar mass, and the 3 oxygen atoms molar mass. And we determine that that's 0.0200 moles of calcium carbonate we're trying to make. Then we're going to use our ratio from the balanced chemical equation to figure out how many moles of sodium carbonate monohydrate that's going to be. So looking at our equation, this one's pretty simple. For every 1 mole of calcium carbonate we're going to make, we're going to need to use 1 mole of sodium carbonate monohydrate. So since that's our ratio, we always put what we're looking to go to on the top and divide by the unit that we're starting with. And that tells us we need 0.0200 moles of the sodium carbonate monohydrate. And then lastly, we have to go back to grams to figure out how much of that we're going to need. So we went from grams of the calcium carbonate to moles. Then we used our ratio from the balanced chemical equation to figure out how many moles of the sodium carbonate monohydrate we're going to need. And then lastly, to get to grams, we have to multiply by the molar mass of the substance. So since we don't normally work with hydrates, I figured I'd show you how to calculate the molar mass of this compound. So since this contains 2 sodium atoms, 1 carbon, and 3 oxygen, we're going to have to multiply sodium's molar mass by 2, get 46, carbon's molar mass by 1 to get 12, and oxygen's molar mass, which is 16 times 3 to get 48. And I want us to consider water its own thing. So water, because it has 2 hydrogens and 1 oxygen, has a total mass of 18. Since we have 1 of them in this hydrate, that gives us a mass of 18. This all totals up to 124 grams per 1 mole. So when we multiply the number of moles that we need times that mass, we get 2.48 grams. And then we do the same thing for calcium chloride. We have 2 grams of calcium carbonate we're trying to make. We figure out how many moles that is. And the ratio is still the same because you get 1 mole of calcium carbonate for every 1 mole of calcium chloride that you use. So same number of moles of calcium chloride required, and then you multiply that by the molar mass of calcium carbonate. So we've determined that we need 2.48 grams of sodium carbonate monohydrate, and we need 2.2 grams of calcium chloride for this reaction. So now I've dissolved the mass of each reactant that we need to. I've put the 2.22 grams of calcium chloride in here and the 2.48 grams of sodium carbonate monohydrate in here. And now I'm going to mix them together and we can observe the calcium carbonate form. And you can see that right away we've formed that white chalky material, that is chalk, calcium carbonate, and now we need to filter this out. So what we're going to do is use a filter paper to collect this. I've weighed this out and it's 0.83 grams. I'm going to place it in the funnel and I'm going to carefully pour my mixture into the filter paper. I'm going to be careful not to go over the edge because otherwise we will have some of our calcium carbonate lost into our filtrate. So ideally we would like our filtrate to be a clear solution of salt water, and you can see that the drop coming out is clear with no chalk residue in there. So now we're going to let this happen. I'm going to filter the rest of this, and then I'm going to rinse it with distilled water, because what's going to happen if I don't do that is any wetness that's left behind when it's going to dry is going to contain salt in it, and that will artificially boost our yield. So we're going to collect both calcium carbonate and salt if we don't rinse it. So, all right, we're going to let this happen, and we'll come back tomorrow and we'll weigh our dried calcium carbonate. So now we've let our chalk dry overnight, and now we've collected it, and we're going to weigh our sample. And you can see that the mass of the filter paper and chalk is 2.40 grams. And just to show you that what the chalk looks like that we've made, it went from being that cloudiness in water, and now we've collected solid calcium carbonate. So now, after subtracting the masses of filter paper from the mass of our product and filter paper, we found that we collected 1.57 grams of calcium carbonate. Since we were supposed to make 2 grams, that gives us a percent yield of 78.5%. Because our percent yield is our actual yield divided by what we predicted we would make, which is 2 grams in this case, times 100.